Can you see my screen?
Yes.
Awesome. Welcome everyone. This is our 7th presentation and I think our 11th or 12th meetup on deep learning adventures. We're a fun, engaging meetup where we talk about deep learning and some cool applications of deep learning, including computer vision, NLP, time series analysis, and so forth. And last week, we had an awesome session with Lawrence Moroney. And if you missed it, we have the recordings on our YouTube channel. But my two very good friends, Robert and David, are joining me today. And we organize this meetup every Friday. And we've been going over the specialization from Coursera called TensorFlow in Practice. And last week, or a couple of weeks ago, actually, we completed it. And we were honored to be joined by Lawrence, who is a developer of the specialization. So if we weren't able to join us, you can head over to bit.ly deeplearning.tf. It's our YouTube channel. And you'll see the recording there at the end of the playlist. But if you're joining us for the first time, this is our meetup here. We have a link here. We have a GitHub repository as well. We have a Slack channel in case you want to join us and work on a project together. And if you're new to deep learning or our meetup in general, all our sessions are recorded and available on this YouTube playlist. This is a small community, so I always find it interesting to get to know each other. If you don't mind, let's just go quickly over the room and just say what's your name and if what are your interests in deep learning, or if you're interested in data science in general. So I'll kickstart it. My name is George. I'm a regular member of this meetup, and I enjoy learning about deep learning and using it in some cool applications like NLP or time series analysis. David?
So my name is David Patton, and I started years ago. I'm a PhD in physics, but quickly moved into software development and have been doing a lot with deep learning lately. Currently working a lot in medical applications of deep learning.
Cool. Robert?
Hi, I'm Robert Craig, also a background in physics. Got into data science 4 or 5 years ago. My interests in deep learning are computer vision and NLP.
Awesome. Kieran?
Kiran. This is the first time I'm meeting in this meetup. I have been to other meetups where I've seen some of you. I have gotten into data science a lot more, deep learning more recently, and I'd like to try to apply some of these deep learning and particularly machine learning solutions to problems that I've been dealing with, largely in economic and environmental arenas.
Cool. Ishan?
Hi, everybody. I'm Ishan. I'm relatively new to computing and all that. I'm a late. I've been introduced in a late way, so I've only been doing this for about a few months now, and quickly drawn towards data science, and with that towards machine learning and deep learning as well. So I'm looking to learn as much as I can.
Awesome. Welcome. Joseph? Looks like you have
there.
Yeah, we can hear you.
Oh, you can hear me now?
Yeah.
My name is Joseph Bonet. I'm from I'm located in Puerto Rico, and one of my projects deals with deep learning, specifically with Keras using R. So I'm really excited to learn more about it and just keep contributing.
Awesome. Welcome. Will? You're muted, Will.
Oh, sorry about that. My microphone itself muted, so I didn't see the little pop-up on my screen. So I'm a software developer that's been working with data analytics, and now I'm starting to get into some more deep learning, mainly interested in time series, I suppose.
Cool. Thanks, Phil. Jyoti?
Yeah, hi. Myself Jyoti Ranjan. So couple of weeks back, I was searching from TensorFlow certification and I come across this in YouTube. Then I joined this group and presently I'm working on the deep learning in the text domain. Yeah, more onto the NLP side.
Awesome. Thanks for joining us again. Sheldon?
Hi everyone, my name is Sheldon and I'm a data science graduate student at GW. And I have taken a machine learning course, and in the coming fall semester, I'm taking a deep learning course. So this is my second meetup I'm joining in. I joined the one with Lawrence Baroni, and that was really good. I really enjoyed it.
Awesome. Awesome. Best of luck with your studies.
Thanks.
Zhao?
Yeah, hello everybody. This is Xiao. So I think I met some of the guys yesterday. Glad to meet everybody here today. I'm a computer vision engineer. I'm currently work for AR startup at the Bay Area, but I'm a remote engineer. And before that, I actually worked pretty long time for the industrial 3D scanning solutions. So mostly use the traditional computer vision algorithms, but also I apply some deep learning combined with the traditional geometry-based algorithms together right now. So I've been using TensorFlow for some time, but also applying to take this certification recently. That's all. Thank you.
Awesome. Awesome. Good to see you again.
You too.
Martin?
Yeah, I'm Martin. I'm interested in reading comprehension and applying it to patent prosecution.
Cool. Mark?
Yeah, hello, I'm Mark. Working currently in system engineering, have an MBA, and I'm new to all of this stuff. So enjoying the meetups. I've been to 2 of them and still kind of getting my feet wet.
Awesome, welcome. And Eunice? Not sure if that's your name or your ID.
Eunice did post in the chat.
There was something on the chat you said?
Eunice says, hello everyone, my name is Eunice, PhD student from Algeria, nice to meet you.
Oh, nice meeting you. Oh, perfect, thanks. Please monitor the chat. It's hard for me to look at it when I'm presenting my screen. Awesome, I think that's everybody. Awesome, well, thank you for coming everyone. It's interesting to see new people. It's interesting to see our regular members. It's interesting to see the community grow and support each other as we learn new concepts in deep learning. So just some quick slide on some attributions that some of the materials we're going to see are from Coursera and deep learning, and I just want to pay attribution to them for their great content. And we'll be using this framework called TensorFlow. It's an open source machine learning platform that can be used in many different applications, including computer vision, natural language processing, time series forecasting, and so forth. Last couple of weeks, we completed this specialization from Coursera called TensorFlow in Practice. If you haven't heard of it, if this is your first time in this meetup, I highly encourage you to check it out. It is made up of 4 courses, an introductory course on AI and machine learning, a course focusing on computer vision and convolutional neural networks, another one that takes a deeper dive on natural language processing, and the last one on time series and forecasting. Well, you don't need a lot of prerequisites to actually take this specialization. You just need some basic programming in Python and some high school level math in terms of matrices, vectors, and multiplication or pointwise multiplication when you're dealing with matrices and vectors and so forth. If you've taken a linear algebra course or calculus in the past, or if you're familiar with deep learning concepts, that's super useful and it would help you a lot, but it's not actually required.
Do you take questions as we go along, or?
Absolutely, yeah, go for it.
On the course structure, right? How does this compare to the deep learning Coursera course that you and I were doing a while back?
Yeah, good one. So actually, Andrew and Lawrence both together in this course, and Andrew gives more the theoretical aspect of deep learning and takes a deeper dive in the theory of it. Lawrence takes a look at it from a software developer perspective. So he will comment a lot on the code. He'll go over the different applications of deep learning. He'll experiment with different hyperparameters. So it's more from a software developer versus, I would say, a deep learning practitioner or researcher.
So they're complements, basically.
Yeah, absolutely, yeah.
Okay.
In fact, Kieran, often Lawrence will refer to a video in Andrew's course when you want to take a deeper dive into the theory. So he doesn't go into the theory very far. It's mainly about the actual TensorFlow application.
Good. Thank you.
You're welcome. And in terms of hardware and setup, we've been using Colab. Colab is basically a free Jupyter notebook that runs on Google Cloud. It's absolutely free. You don't need anything. You just need a Google account. And you can run your code, you can share it, you can comment on it, and you can run code and train your models, I think up to 12 hours each time without any cost. Cool. Today we'll talk about the TensorFlow Developer Certificate. And if you're familiar with TensorFlow, this is a relatively new certificate. I think it was announced in the last summit back in March. I'll go over 3 parts. First of all, what is this certificate and how can you prepare for it? What is the content that you're required to prepare for this exam? How can you best prepare using our recorded session on our YouTube playlist as well as our GitHub repository? That's on the content end. More on the hardware side, and we'll take a deeper dive when we get there. You'll actually need to use a software called PyCharm. It's an IDE, integrated development environment, where you'll download a plugin and take the exam there and submit your answers as you go through them. There's, I think, five different questions that you need to answer, and they increase in terms of difficulty level. If you have a good deep learning setup already, you're good. You just need to install PyCharm and experiment with it a little bit. In case you don't have a good deep learning setup, like in my case, I'm using a Mac, and Macs are not that popular when it comes to GPUs. They have a GPU, but it's not that strong. I actually ended up using a deep learning virtual machine on Google Cloud. You can do the same on AWS or Azure or any other cloud provider. And then some tips and tricks that I think are useful as I went through this process that I think are very useful, especially if I was taking this exam again. Any questions about the structure or comments? Cool. So as I said, this certificate was announced several months ago. It's a way for TensorFlow developers to differentiate themselves and also share with their network this achievement. So this is the TensorFlow page mentions this as an introductory level 1 certificate exam. It builds on foundational knowledge on machine learning and applications, including computer vision, convolutional neural networks, natural language processing, real world image data, and strategies. Why would you want to take this? If you want to learn something new, if TensorFlow you've been using it for a while, or you want to look at it from more of a community recognition, or you want to showcase your skills, that's a good way to show this by taking this exam. If you're looking for talent, there's something called a certificate network where you can search for people who actually have passed this exam. And once you pass this exam, you'll be part of that network as well. So if you're trying basically to ground your knowledge and you want to showcase it to your community that you want to advance your career or your project, it's a good use case. The TensorFlow Certificate Network has about 345 users as of today, and 65 of them are located in US, Canada, and Mexico. If the exam itself costs about $100 or $100, and if you remember our conversation with Lawrence last time, he mentioned that there are several educational stipends available. So if you cannot afford the exam, or if you cannot afford the training materials, you can apply on this link, and TensorFlow team is more than happy to assist you.
So I'll just put it out there that I went through the application process, and they haven't got back to me, but they do say it's a 4 to 5 week approval process. Maybe they'll be fast. Maybe they're hedging their bet, and it'll be a lot faster than that. But just for everybody's aware, it may take a month or more to get approval for the stipend.
Got it.
But for those that need it, it's a good thing to go for.
And
yeah.
When you say stipend for training materials, you're talking about the Coursera course?
Yeah, Coursera course, or maybe a book you want to buy, or something else. Yeah, but I think it's mainly the Coursera course.
Yeah, that's my understanding.
Cool. How does it actually work in 6 steps? So you need to review the candidate handbook covering the exam criteria and FAQs. To actually prepare for it, a very good place to start is a TensorFlow and practice specialization that we just completed as a community. The exam team actually strongly recommends it. Then the next step would be to actually register for the exam. All you need is a Gmail account. You upload your picture ID, or such as driver's license or passport, and you provide payment information. Then you need to prepare your exam environment. You need to install the PyCharm IDE as well as the TensorFlow exam plugin. And there are links in their website here. Then once you're ready, and by the way, you can do steps 1, 2, and 3 way in advance, weeks or months in advance. They're completely unrelated to when you actually take and submit the exam. So once you're ready, and once you're comfortable with your setup and your training times and your accuracy and the different content, then you can actually take and submit the exam. You have a maximum of 5 hours to complete the exam, and you'll be given 4 or 5 questions, increasing in difficulty, and we'll go in detail. Then once you do that, I think it takes a couple of hours, or maybe the next day, you actually get the certificate, and you are also entered in the certificate network where you can share with your community your achievements. Any questions about these steps? We'll go in detail soon. Great. So on their website, the TensorFlow team mentions that in order to take this exam, you should be comfortable with foundational principles of machine learning and deep learning. Anything from what is a neural network, what is an activation function, what is a input layer, output layer, intermediate layer, or hidden layers, to convolutional networks, to natural language processing, to time series forecasting. You need to be comfortable with building machine learning models in TensorFlow 2.0. And some examples here include building image recognition, object detection, text recognition algorithms using either DNNs or CNNs. Then you need to work with images of different shapes and size. You might be asked to visualize the journey of an image, as we've seen, through different layers, convolution and pooling layers. You need to make sure that you're not overfitting your data, your model is not overfitting on your training data. So you may have to use techniques such as augmentation and dropouts, as well as using neural networks for natural language processing. So think of it like sentiment analysis that we've done, or classification in terms of movie reviews. If this is all new to you, or if you're not quite there yet, the exam team recommends taking the TensorFlow and practice specialization. And again, we went through that for the last 2 months, and all our sessions are recorded on YouTube. It's highly recommended simply because the questions, I think, were derived from the specialization itself and the courses themselves. There's also a Udacity course on Intro to TensorFlow for Deep Learning, in case you want to check that out as well. You need some basic skills on Python, as well as machine learning and deep learning, and some mathematical background on linear algebra and statistics. So yeah, that's the TensorFlow and practice specialization that I talked about. The Udacity one that Lawrence also mentioned. Some basic skills on coding, math, and stats. Some the theory of machine learning, and some experience with hands-on hands-on experience with actually building and hyperparameter tuning your model, and looking at not overfitting it, and seeing the loss function over time and so forth. On the website, there are some other resources like books, online courses, other resources, math concepts, and something called human-centered AI. You can check it out. I don't think they're necessary for taking this exam. If you've taken the TensorFlow in practice, and hopefully after we go through this presentation, you should be in a good place to take it. In terms of content, there are 4 main content chapters, and they actually resemble a lot the TensorFlow in practice courses. There's a basic one where you build and train neural models using TensorFlow 2.0, pre-process the data using models to predict results, using sequential models as we've seen with multiple layers, binary or multi-class classification, looking at the loss and accuracy, making sure you don't overfit, and in case if you are overfitting, then what techniques can you use to avoid that? Using pre-trained models as we've seen with transfer learning, especially in computer vision, extracting different features from pre-trained models and then building your own neural network on top of that. Batch loading, different data sources, using data sets from TF data datasets, that's very important. Different formats, I think so far we've seen CSV, we've seen JSON, we've seen text, so being familiar with different formats as input is super useful. So you will get one question for sure on one of these related topics, and usually the first question is very easy. You can knock it off relatively easy. Then the second question is related to image classification. You need to work with convolutional neural networks and Conv2D and pooling layers, as we've seen, probably with real world images.
George, when you just maybe we'll go through this in a second, but when you say question, is the concept that each of these questions involves building something in PyCharm and then submitting it, or is there actually a like multi-choice question and answer part of the test, or is it all?
Yeah, it's actually 5 different folders, and each one of them requires you to build a model. The model that you build generates an H5 file. That file gets sent to the TensorFlow backend and gets evaluated on a test data set for accuracy.
Okay, so each of these concepts or areas of concepts is how you can put it into practice. It's not like they're asking you a set of multi-choice questions,
no.
Choose the best answer kind of thing. Okay,
yeah, there's no multiple questions. No, it's similar to how the end of course exam or
the exercises.
Yeah, so if you have a skeleton, it's kind of pre-built. You have a section where it says insert your code here. And you can insert your code there. Usually the model is missing, or maybe the pre-processing step is missing, but the libraries are there. You don't have to include any new libraries.
Okay.
Then you have a define model basically method. Then later on you call it, it generates, you save the model as an H5 file. That gets sent over to TensorFlow team for evaluation on a test data set that you don't have access to.
Great, thanks.
Yeah. So image classification, augmentation, preventing overfitting, image data generators we've seen, and also customizing it based on the directory structure that you have. So we've seen, for example, like human and horses, or like rock, paper, scissors. You have to make sure that your image data generator reflects that data structure.
Do the exam problems communicate to the test taker what kind of performance is expected on each question?
Usually, you get a point out of 5. So when you submit your model for evaluation, it will run on that test data set. You'll get a number that I think is reflective of the test accuracy. So I think to pass it, you need maybe at least 80 or 90% accuracy. But you don't get the number back. You just get 4 or 5 out of 5.
And then
so I think you have to get all 5s, or maybe 1 4 out of 5 out of 4 or 5 questions.
So if you're looking at your data and you're saying that I'm getting 90% accuracy on the training set and 85% accuracy on the validation set, there's no way, like, they're not telling you have to get at least 88% on the test set or something. They're not communicating that.
No, they're not telling. It's automated. They're not telling you any numbers. They're just giving you something out of 5, an integer out of 5, 1, 2, 3, 4 out of 5, or 5 out of 5. So let's say it's in increments of 20. So you're getting 20% accuracy or 80% or 100%.
And then if you submit it and it doesn't pass, you can just keep working on it during the 5 hours?
Yeah, you can submit it as many times as you want. Yeah, it's automated. You can submit it 10 times, 100 times. Save and submit. That's the flow. Kiran, you had a question?
It was the same question that Robert just asked.
Okay.
Is it more like Coursera Summit?
Cool. Then the third question would be on NLP. It could be on sentiment analysis, or it could be on some kind of multi-class or binary classification or categorization. It could be on word embeddings. Could ask you to actually use RNN or an LSTM network to do some kind of binary or multi-class categorization. And you're free to use as many layers or as to create your model as metrics like moving average error and all the different techniques we've seen on how to improve the MAE. Robert and David and I covered this extensively last time, and what techniques can you use to make sure that your MAE, your error, is as low as possible?
George?
Yes.
Is it more like Coursera assignment submit? Like one block of code will be there, something will be missing. We have to fill like that?
Yes, exactly. Yeah. So you have a skeleton code that's already pre-populated for you, and you have a missing part that you have to fill in. Another concept here, identify and compensate for sequence bias. If you look at the code, you need to shuffle your data before training so that your model doesn't pick.
George, when you say you have to run it in your computer, does that, I mean, like in Coursera, you sort of like had it running, I think on the Coursera's running on your computer and you're just submitting it?
Yes.
AWS or something like that.
Both options are on the table, yes. And so all the questions, if you notice, they're actually closely related to the structure of the specialization. So if you're very comfortable, and also our trivia games, I think you're in a very good place to take the exam.
So my understanding is there's,
I think 4 or 5. I don't remember, to be honest.
Okay, I guess there's something.
Yeah, there's probably some crossover. Yeah.
Okay.
Or maybe something you haven't seen yet. But yeah, for sure you're gonna get a question from course 1, sure. And again, if you haven't, if this is all new to you, or if you want to refresh, we have all our sessions recorded. You can go through them to part 1. Part 2 takes a deeper dive on the mechanics, on the hardware part of it. How do you actually make this work in 5 hours and using your hardware? And then part 3 is a little bit of mixture of part 1 and part 2 on where to pay attention. So as I mentioned, you can install this IDE called PyCharm, and I highly recommend you do that way in advance, and you get familiar with the look and how do you actually plot something and so forth. The exam can take up to so forth. If you haven't submitted 5th hour, and I have a screenshot here that says submit and test model. So for example, this is like the second question, and when you submit and test, it will just give you a score of
less than, then we can resubmit again also for this
data set. That test data set could be shuffled. You might actually get a slightly higher examples you're testing on might give you 5 out of 5.
Okay.
So
okay.
A little bit of
Another,
there.
yeah, another in line. Are there monitoring some monitoring cameras? We have to on that, or it's just
no? There's no monitoring cameras, and I think I explained it in the next slide.
Okay.
That you can use whatever you want. You can Google it. You can, well, don't ask your friend, obviously, but you're free to do whatever you want. Think of it as a take-home exam. You can research, you can Google, you can troubleshoot it somewhere else. If PyCharm is not the place where you troubleshoot or you feel comfortable, if Colab is the place, that's also what Lauren said. You can copy paste the code in Colab. You can troubleshoot it there. I ended up doing that for one question. And I have some tips and tricks later that you have to pay attention to.
Okay. Sure.
Yeah. Go ahead. Kiran?
spend all 5 hours doing the exam?
Say it again.
Did you spend 5 hours
Oh no, I did not. No.
doing the exam?
No.
Okay, so it's more than adequate.
Yes, yes, yeah. They give you a lot of time, especially if you don't have a strong GPU. They give you a lot of time. Yeah.
And roughly, if you're thinking about how many lines, I mean, because you're just filling in code blocks, right?
Mm-hmm.
I mean, how much? I mean, are we talking about 40 lines of code, or are we talking about 5 lines of code? Writing.
So the difficulty goes like this. It's linear. So yeah, in the beginning, it will be just very few lines of code, but in the end, it could be tens. I don't think it'll be 100 lines of code.
Okay.
Yeah, good questions. In terms of validity, it expires after 36 months. Hopefully by then, another version of TensorFlow will be available, or maybe a better version of taking this, simply because of the mechanics that you'll see soon. I highly recommend going over the installation of PyCharm and checking your GPU drivers and Python 3.7, how to create a new PyCharm project. It's basically a new environment. It was new for me, so I had to spend a lot of time in advance for this. And they recommend using PyCharm version 2020.1, which is not the latest. You can use either the community edition, which is free, or the professional edition, which is free for 30 days. I ended up using this free for 30 days, and it was enough for me to prepare. You can take it on the community edition as well. So the question is, should I use my setup or should I use GCP or AWS? And I have a very simple test for you. So if you go to our GitHub, or if you go to your TensorFlow in Practice specialization exercises, just pick any of them for each course and see how much time does it take for you to run it. So look, for example, at how much does it take for your model to run per epoch. What is your loss in accuracy? And we have some benchmarks on GitHub. So for example, for this convolution neural network, 1, 2, 3, 4, 5 layer of classifying human versus horses, it took on Colab about 19-20 seconds to run per epoch. So if you have 20 epochs, you have to keep that in mind. Also look at the loss in accuracy from the training set, as well as the validation loss and accuracy. Run it on your local computer. If you're getting something comparable, or maybe a little bit higher, or maybe a little bit lower, I don't know, I think you're in excellent shape to take the exam. If you're...
Was that with GPU on Colab? I think it was, right?
Yeah, it was GPU, yeah.
Okay.
It was GPU for this notebook, yeah. If you're like 10 times higher than that, let's say you're 200 seconds per epoch, then definitely don't use your setup, and I have a plan B for you coming up next. Does that kind of give you an idea of local versus remote setup? Okay, cool. Then, yeah, as I mentioned, if you're getting hundreds of seconds per epoch in that data set or similar data set, then you need a stronger computer or a stronger setup. And I didn't want to spend money on buying a new computer. We have the cloud for that. So you can rent a basically VM for as much as you want. You can start and stop it whenever you want. You don't get charged when it's stopped. And the only thing you have to keep in mind is just setting it up and turning it off when you're done. So both...
Lawrence did not mention stipends for computing power.
I have a slide for that, how much it costs. But both Google Cloud and AWS have deep learning VMs. If you look at the Google Cloud, I ended up going with Google Cloud. I use both. I use actually AWS at work, but at home I use Google Cloud. There are different GPU versions. The challenge for me was I wanted one that's close to me, simply because of the delay. I didn't want to waste time, sending packets over to remote data centers. There was nothing in Northern Virginia one. There's nothing in North Carolina. There was nothing in Northeast. There's nothing in Midwest. I had to go all the way to Washington State, Oregon somewhere. I don't know what that was, West 2 or something, to actually get a GPU to get a VM with one GPU. Like, okay, fine. And you'll see the cost. It's not that significant as long as you don't forget to turn it off when you're done. during the day. Any questions? Let me know. XPS notebook integrating GPU.
So this NVIDIA GPU, that's if you buy the graphics card, or what is that called?
Yeah, this comment is if you, just to give you an idea of the different GPUs. So when you rent one, you'll see what kind of GPU do you want. And obviously the higher ones, like the more expensive one is to buy, the more expensive it is to rent. I ended up using the T4. It was relatively inexpensive to rent, but also had very good statistics. And Eunice, in terms of your question, I don't know if an XPS notebook, what are the specs for it, but if you go to this link here on our presentation, if you download this Jupyter notebook and if you run it, if you're getting something 20, 30, 40 seconds per, even 50 seconds, you know, twice as that, I think you're good. And also keeping an eye on accuracy. But if you're getting, you know, 10 times higher, then I think you'll have issues simply because you'll spend most of your time waiting for your model to train. You can work on 2 different questions or 3 different questions, but you can only run one at a time. Then I knew this would be an issue, so I was thinking maybe I need 2 GPUs. So in GCP and AWS, you can do that. You can edit your quota. And then GCP says, hey, I can't give you another one. So I kept trying multiple times. You basically end up having just 1 GPU. Once you do that, there's a step to actually move all your data and all your setup into this remote VM virtual machine. You have to copy all your data set, all your data, all your models, so you can run them. You have to install PyCharm. You actually run it from a command line. I had to run it from this Debian 9 virtual machine. And in PyCharm, you can look at what is your Python interpreter, and also most importantly, what are your different Python packages like TensorFlow, TensorFlow dataset, estimator, and so forth, and their version. Yeah, please monitor the chat, or if there's any question, let me know. Okay, how much does it cost and how long did it take for me? I started the exam on 3:38. By 5:10, I was done with 4 out of 5 questions, I think. Yep. And there was one question, it was actually question 2, which I thought, this is an easy one. But question number 2 took me the longest to solve, simply because it was a new data set. It was a new data set, and I had to become familiar with it, you know, during the exam. So for about 15 minutes, I had to troubleshoot that. My environment on the Debian 9 wasn't the best environment, so I actually started using Colab to troubleshoot this question. The issue I faced there is that you might have different version of TensorFlow or datasets, and the commands might be slightly different. So you might have to actually downgrade your Colab datasets or TensorFlow to actually match the one that you have in your Google Cloud or AWS virtual machine. And in terms of cost, when I was renting this VM, I started, you know, May 15 for like 10 days. It cost me about $23. So it's not that much, I would say.
So 10 days is for what?
So I was preparing, I took the exam on May 24th, but I was preparing in advance for this. And you can see the cost. So on one day it cost me $2, another day it cost me $3, based on how much time I spent. So the more time I spend, obviously the more I pay, but it's in the matter of a few dollars per day to prepare.
And are they still running the $300 credit for new?
For new accounts, yeah, I think they are. So if you never used any of this, you get $300. Yep.
This is
how much actual compute time was that? $2-3 per day.
So it was maybe 2-3 hours a day. It wasn't like full
2-3 hours on one GPU.
Yeah, 2-3 hours on one GPU.
And the credit was with GCP or AWS?
I think they both give you credit if you're a new account user. They both give.
Yeah, the $300 was, at least Google's been running that for a while for new users.
Yeah. So yeah, so the exam took about 2 hours for me to complete, and I spent most of my time in the question number 2 on a different data set. So that's the cost and the time part of it. Cool. Any questions so far before we go to the last part?
Retake the exam 10 times on the amount they give you for credit.
10 times, $300? Yeah. You're not going to use all of it, don't worry.
I had a doubt.
Yeah?
I'm Sheldon. Yeah, I had a doubt. So you said you had to set up, like there was some version conflicts with your GCP virtual machine and the version for when you were taking the exam. Is that right?
Yeah, and I'll get to that in the next slide. Yep.
Okay,
Good.
yeah, I'll yeah, thank you.
Absolutely.
So George, it wasn't clear to me, and maybe you said it, but I missed it, about how are you running PyCharm on your desktop or on the GCP environment?
So this is running on the GCP environment, and
Okay.
there's a way for you to set up what is called a remote connector to your GCP environment. And you actually have to set up your VM for a remote desktop, because by default it's just Debian Unix. By default, you just get a command line.
Right.
But you need the actual GUI to install PyCharm, to run it, update it, whatever you want.
Okay, and then you're running the Linux version of PyCharm on the the remote desktop.
You see, there's a command line here. I have to start it. There's a way to start it, and there's a way to stop it.
Okay, perfect.
Yeah, not the most user-friendly way. Cool. In terms of some tips and tricks, as I mentioned, steps 1, 2, and 3, you can review the handbook. You can take the specialization way in advance. You can even register for the exam way in advance. You can upload your picture. You can provide your payment information. You can even pay for the exam way in advance. You don't have to take it after you pay. You can take it days or weeks later. And make sure that you prepare your exam environment again.
Advantage to doing it early?
Is
there any advantage to doing it early? Are there like limits on how many people can take the exam at a time or something?
There's no limit. I registered for the exam and I paid for the exam that day, and it took me about an hour or two to actually get approved. So I think they rely on a third-party company, I think called True Identity, and I don't know if somebody physically verifies your picture ID with the picture that you take in front of you, but that verification process takes like an hour. So that's a little bit nerve-wracking because I'm like, okay, I can't take the exam until you verify my ID. Then I have to install the exam plugin. I have to get it running, So you can do this way in advance, I'm saying.
Yeah, so basically, I mean, by way in advance, you mean, if you feel that you need to prepare a little bit for the exam, it's part of that, right? I mean, it's like the beginning of your 10 days, you would just schedule that, right?
Yeah. If you know the next couple of weeks,
you need to do it months and months ahead.
Yeah, if you know, weeks. If you know a couple of weeks from now you're going to take it, do it 2 weeks in advance.
Yeah.
Or even a week in advance. Even a day in advance, you can do it. I'm just saying, just cross it off your list.
Sure.
Then, if you want to look at other people's experience, other users' experience, you can search on Medium. David found a good post. There are more and more people now posting on Medium. I'll post one as well on the experience and detailed steps. But you can see other people's experience and how they troubleshoot these different issues and where they spend most of their time.
George, Lawrence, I think, said that you had to use this clunky PyCharm environment because it helped. It prevented cheating versus using a simpler interface. Do you know what he was talking about, like how it served that purpose?
Yeah, so we asked them why couldn't this be done in Colab, and they said that Colab didn't have any features to verify your user account or your ID, and didn't have any features to make sure that it is you who are actually running it and you're not impersonating somebody else or using somebody else's code. So
that was that hour setup you were talking about then?
Yeah, that's the PyCharm setup, yeah.
Okay.
And I think it's the
PyCharm you have to do anyway. Now the question is, do you do PyCharm on your computer or you do it on the cloud? That's the only question.
Yeah, and I would also say that I think from what Lawrence is saying, I mean, part of the thing is it has to deliver a specific test personalized to you, down to you. And that's hard to do in Colab. It's not really set up to do that. Just to be clear, PyCharm is a very advanced IDE. It's the #1 Python IDE out there. We just are all used to writing in Jupyter notebooks and stuff. So, but yeah, and the enterprise level, PyCharm is the go-to standard for Python.
Okay, thanks.
So it's very advanced.
Yep. So yeah, my second tip is get to know PyCharm in and out. You can make sure you're comfortable with it, make sure you can install it properly, and also get to know how you can add or edit your interpreter. And that's very important, especially if you do the cloud version. Is there a question, Peter? Yeah. Then you also need to know where to find your packages and how to upgrade your packages. And that brings me to my next tip. So when you install the certificate plugin, you'll see that it will create a virtual environment on your setup. Now that setup could be local to your computer or on the cloud. You'll see it will install TensorFlow 2.0, which is not the latest version. It will install NumPy 1.18. None of them are the latest version. This is probably like months old, all of them. URLib, in case you want to bring things from the internet. TensorFlow datasets 1.3. This is definitely not the latest one. And Pillow 7.0 for image preprocessing. So you only need 5 packages to actually run this exam. And if you look at, if you go to the packages folder configuration, you'll see the different versions, and it's very easy for you in PyCharm to say, okay, update to the latest one. And my next tip would be that the first thing you do is A, update TensorFlow, B, update TensorFlow, at least TensorFlow. I'm not sure if you have to update TensorFlow datasets. That actually might break some of your equations. So just update TensorFlow for sure, 2.0 for example, 2.2, even before you start the exam. Question is, why should I do that? So I have 2 graphs here. The one on the left is TensorFlow 2.1, which is even higher than the 2.0, exact same data set. And on the right, I have the 2.2 version of TensorFlow. And you'll see on the training, so training is dot and validation is a solid line. So with training data set, I'm getting about 90% accuracy here versus 96% accuracy with a slightly higher version of TF. And similar for error, my error with 2.1 was about 0.3, with 2.2 was about 0.1, like half. So just using a higher version of TensorFlow, I'm getting significantly higher performance. Question on the chat.
So what you're saying is when you installed PyCharm, you only initially got TensorFlow 2.0 or what?
Yep. It's a virtual environment, so it's like a setup script.
Okay, and that script was created by who?
By the TensorFlow certificate exam team.
By the TensorFlow certificate exam. But apparently you're not actually stuck with those versions of the packages.
No, you can update them, yeah. They install it, but you can update all of your packages.
Without actually breaking anything.
The datasets one might break, so I'm saying don't do the datasets. Just do the TensorFlow. Do also the TensorFlow estimator. I read it online that people did that as well. I'm not sure if it helps or not, but for sure TensorFlow.
And you have to do this within the 5 hours?
Yes.
Well, okay.
Yes. The moment this happens, you already the clock started ticking. The moment you start installing this. Exactly. Yeah. So step number 1, just update it. That's why I did. I updated TensorFlow to the latest one, and I started looking at the different questions. Then I have some common issues and useful links here for using the GCP route. Again, if your environment is fine, you don't have to go through this. But if your environment is not strong enough, then you have to go through these hoops and loops, unfortunately. So first you have to install the 2020.1 and only that version. Don't install the latest one on your VM. You can, the way that actually I did it, I installed PyCharm on my Mac, but I configured my interpreter to be remote on the cloud. I thought I could get away with that because it's PyCharm, it's on my Mac. I can get used to the UI and look and feel. I can copy files directly. It's very easy for me to do that. But on the interpreter side, you can point it to a remote interpreter, and you can specify like a secure file that basically allows your local PyCharm to communicate with a remote backend. I thought I was fine with that. During the exam, apparently I couldn't do that. So I was like, what is this? You actually have to use the remote one. No, not during the exam. I figured this out way in advance that you cannot actually do this. You cannot use PyCharm on your local computer and a remote Python interpreter. So basically the whole thing has to be remote if you're going with cloud. There are some issues there if you want to upload visualizations. There's a link here on how to make sure that you have to set up an environmental variable, how to make sure that that works for you. You don't have to upload any visualizations during the exam. You can maybe look at the model.fit output. Yeah, how to get your SSH keys. This is needed if you want to SSH, obviously, through your remote machine. How to set up this remote desktop. Chrome has an extension. It's called Chrome Desktop Remote, where you actually log in to a very lightweight application that gives you this GUI that you're looking at. So this GUI is actually running on the cloud, but it's an application running on your local computer in terms of access. When you start and stop your VMs in the end of each day as you're preparing for this, your VM might actually change IP. It's ephemeral, it's temporary. So if that happens, you might have to know the new IP to actually SSH to it or open it. And as always, when you're working with cloud, don't forget to start and stop. Don't forget to stop when you're done. Otherwise, you're just going to be paying for it for no reason. So there's a lot of content here. The best advice is just prepare in advance if you're going the cloud way. If you're a local path or a local way works fine, then you don't have to worry about this.
Judge, suppose in the exam also, like Lawrence told that, right? If my local is not performing, I can run this code in the Colab. If it's working, then can copy it and paste to this PyCharm in my exam folder, right? Will that work, right?
Yeah. The only issue there is do tf.version. Make sure that it matches the one in PyCharm. Do tf.datasets version. Make sure it matches. For me, it didn't match. For me, when I was troubleshooting this in Colab, so I had an issue in PyCharm. It was very tricky for me to troubleshoot it here. The command, the command C, command V was different here than on my Mac, so the keys were slightly different. So I wasn't comfortable troubleshooting it there, so I did it in Colab. But the exact same code in PyCharm in Google Cloud, when I copied it here, didn't work in Colab simply because the TF dataset had a different version.
Okay.
So I had to downgrade my TF dataset to the one that the exam setup was using.
Okay. Okay.
Yeah. And yeah, so you'll get some questions that you probably haven't seen in the specialization. My best advice for that is look at the TensorFlow tutorials and TensorFlow datasets, especially the dataset one, because it has so much content on like image classification, it has content on structured data, which we haven't seen yet, and I recommend we look at it. On text, you're not going to get asked on video or something that is completely different, but looking at these data sets and also the tutorials will definitely prepare you for the unknown question, which I think it's part of the recipe. You get asked for 4 questions that are relatively contained or included in the specialization, TensorFlow in practice, but I think there will be one that you haven't seen yet or a data set you haven't seen yet. That's all I had. Sure, you might have some more questions, happy to answer them, but basically for me, the exam itself, the questions weren't hard. Maybe one was a little bit tricky, but for me, preparing for it and getting this environment set up was the most time consuming. I just happened to do it way in advance and, just knock it off the list. Cool. That's all I had for the certificate. I have another portion on some next steps as a meetup, and I'd like to open it up for everybody's opinion. But we've been basically we completed this specialization together. We started in April, became a stronger community, very good friends. And what could we do for second or third adventure? And think about it. I have some recommendations here, but what I was thinking is we could look at the different tutorials and maybe structure data. That's something we haven't done yet. The tutorial itself has some good examples on structured data, on how can you use deep learning to solve structured data problems. We can probably work on Kaggle notebooks or actually join an actual competition. That would be interesting. We can collaborate maybe with other events or other meetups or other organizations, maybe host some kind of a hackathon, a deep learning hackathon for good. Maybe there's a challenging data set for us there. We can work as a team. The other session I'm recommending is coding related. That's always useful, but basically a coding session on real world data, and that could be on computer vision or sequence models or time series. So if you have any data sets in mind, or if you actually have a problem at work or from your hobbies that you'd like to share, we're happy to consider that. That's more of the hands-on structure or path. The other one is we continue with other specializations or books or more basically training. And YouTube has such a great content, especially from Stanford, MIT courses. There's courses on machine learning. There's courses on computer vision specifically. There's courses on NLP that are pretty good. In terms of specialization courses or online books, I have links here that we could continue our journey in TensorFlow by taking the data and deployment specialization. To me, that feels like a natural next steps, simply because it's based on TensorFlow and it's also developed by Lawrence. So it feels like a next step. This one actually relies on using TensorFlow on edge devices, or your phone or other lower power devices. So it might be actually more practical for people who use it on the edge. Coursera has a new natural language processing specialization. They only have the 2 out of 4 courses yet, and it looks pretty interesting. There's also AI for medicine and AI for healthcare from Coursera and Udacity as well. I want to make sure I ask David in the end on his experience so far, but if medicine or something you want to get into or something you do as your job, then maybe you want to explore this path as how do I use deep learning to solve challenging problems in medicine. There's a new resource, I just found it today. It's called Full Stack Deep Learning. It has content from a lot of great lectures. It actually covers the entire path, not only how you use your model, how do you train your model, but also how do you deploy it at scale, and how do you serve it to users. Google has a machine learning crash course. MIT's lectures are in this website, Intro to Deep Learning. I know, Robert, you mentioned, I also was considering Fast.ai, which I think is based on PyTorch, if I'm not mistaken. Yep, Kaggle has a great learning overview on machine learning, also data science. This is data science and machine learning. François Cholet, the author of Keras, the original author, has a deep learning book on Keras. It's online.
Excuse me, George. Does PyTorch use Keras as the front end?
It's a completely different framework.
Okay.
Yeah, it's completely different. Then, yeah, Ian has his deeplearningbook.org. He's known for bringing GANs, generative adversarial networks, into the picture. There's also a neural network and deep learning interactive book that's out there. I can take a deeper dive to any of them. I'm just curious hearing more of, as a community from David. I think he's taking so David, can you tell us a little bit more about the data and deployment as well as the AI for medicine, since I think you're taking both of them, or you've taken both?
Yeah, so I've completed data and deployment specialization. It's a very natural follow on to the TensorFlow in Practice one that we just completed. It is, again, it's very developer centric, not theoretical, but it's nice in terms of if you're interested in looking at how to deploy these things out to your phones or to edge devices, microcontrollers, and different things. It's a very it's kind of the next step of we've gone through how we build models. Now, how do we actually get them out there in the real world for use? And it tends to focus on a lot of that, as well as the other side, which is how do we bring the data into our models? So it's kind of like taking that look at it.
Got it.
But it is very, very programmer oriented. It's taught by Lawrence, so you would expect that. I'll throw out there that, you know, no matter which one of these we choose to do next, you know, maybe hopefully I'm not cursing us because it went so well, but I would say it might be interesting to invite more people to join us every once in a while. The experience with Lawrence was really good. And, you know, if we could get some of the, you know, people that are experts out there to occasionally speak on a topic with us, I think that was really, really neat. And we learned a lot from it, I think, you know.
Yeah, we'll try. Yeah, it's of us. You know, we can reach out on, you know, LinkedIn or social media. Yeah, hopefully.
Yeah, I mean, it would be hand in hand with whatever we choose, whatever direction we choose to go, whatever topic. But I thought it was a nice compliment.
Yeah, I agree with you absolutely. Yeah, I talked to Lawrence. He's more than happy to join us in the end of this data and deployment.
I bet he would. Yeah.
Yeah.
So I'm about to finish the AI for medicine. It's interesting. It is very domain specific in terms of, you know, there's a lot of discussion about the types of metrics that you use in the medical field, or the types of, you know, the types of data, how it's different from what we're normally using. There's not as much, they call it AI, and there's not as much deep learning. I mean, you do go through using some CNNs for classification. There's a little bit of NLP for some of the text type of work, but it's not as much oriented toward deep learning. I'll put that out there.
When you say it's not as much oriented toward deep learning, is it also not as much oriented toward machine learning? Because AI is a really broad thing, and machine learning is kind of a part of it, and deep learning is a smaller part of that.
Yeah, absolutely. I would say it's got more of the machine learning, but I also would point out, you know, probably 75% of the course is learning the types of metrics and the lingua, and the different types of data that the medical fields are involved with. So,
which is a challenge that data scientists face as they transition between fields at any point, right?
Absolutely, yeah. So if you're interested in medicine, I highly recommend it. I mean, it's, you know, the Udacity has one too, which I have not taken, so I don't know if it may be very similar.
Yeah, I haven't taken it either. 2D medical images, 3D medical images, EHR, wearable, looks like a bit more advanced or more in detail.
It looks a little more specific, yeah. But the Coursera one is broader, I would say, than that.
Yeah. Also, the cost is different here, right? The cost here is usually higher.
Yeah. Although I think right now they have some special, well, they may have just ended it. They had some special.
They have a special for 1 month free, but if you look at the reviews online, they're not the best. It's very hard for you to stop that even before the 1 month ends.
Right.
And I'm a fan of Udacity. I've actually taught at Udacity before, and
okay,
I'm a big fan of their mission. But this new cost structure, like I think it was introduced last year, it's pretty high.
Yeah,
I feel. Cool. Let's look at some other resources. Yeah.
George, during Lawrence's session, at the end, there was a young woman asked about energy stuff, and so I connected with her on that. She's working on smart grids and detecting fraud, stealing electricity in smart grids and applying machine learning. We actually looked at a couple of papers on that. Would you be interested if she would kind of talk about her project and you guys give her feedback or we give her feedback, that kind of thing, or not?
Yeah, I love that. Yeah, that'd be a great session for us as a group to work on a real world problem. As long as, she doesn't mind sharing, or maybe it's another data set that.
Okay, well, maybe I'll connect her with you, and you might want to talk about.
Yeah, if you know any other people who might need help with similar applications, we're happy to consider it. I consider our community not only academic in nature, but also hands-on. Let's see what we can do for this challenging problem.
I would also invite people to be sharing any projects they're interested in at the happy hour events that we've been running as well. For those who are new to us, after every one of these 4 courses, we took 1 week break from the course material and just had a free-for-all session. Called it a happy hour. You can drink if you like. You certainly don't have to.
Yeah.
And just shared topics related to deep learning. Had a variety of interesting discussions. I think we played with MobileNet models one week, which was a lot of fun as well.
Yeah. Yeah, there is a Slack channel as well, David or Robert, if you don't mind sharing the link.
So if anyone has a project that they'd like to talk to us about, but doesn't want to necessarily make an entire week's presentation for, the happy hours would be a great time for that.
Yeah, or if you want to talk about your project, we don't have to host. If you want to talk about your project, what you've been working on, or where you're stuck, you can give a quick presentation to us, and we're happy to do that. Cool. Just quickly giving you some more ideas here. But actually what I'm going to do is next week, maybe we can have a happy hour and get some feedback on all these different topics and questions, or maybe projects. I think that'd be a good next step. So natural language processing one goes more into vector spaces classification, NLP with probabilistic models. This looks like the Ngram or the previous applications before deep learning, if I'm not mistaken. Then using sequence models like RNN, LSTM, and actually using attention model, which is based on transformers. So this looks like a very good course for us as a community, I feel, simply because it builds on top of the deep learning specialization as well as the TensorFlow and practice specialization.
Now we've only got 2 courses actually completed there so far, right?
Yes. One.
Whose course is that?
Which course is this?
No, I mean, who's teaching the course?
Luca is actually one of the authors of the transformer model.
Right.
Yunus, I think, is a student of Andrew. And Eddie is always there as a curriculum developer. Yeah, if you Google for Lucas, he has some great videos online, especially when he explains the transformer model.
Yeah, I know when I took the deep learning specialization, I was really enthusiastic about doing it. And then it took months and months. I think the 5th course was promised, and it took it took a while for them to actually finish it. So I'm a little bit hesitant to jump into courses that haven't been finished, because you might take a while.
I'm actually better testing some courses for Coursera, so I can probably have some tips on when they would think would be done. Cool. This is the latest one, or the newest one that I found today. It covers both how to create a model, but also what is the cost if you deploy it on the cloud or in your infrastructure, troubleshooting it, deploying it at scale. Has great authors, as well as guest lecture. Like the guest lecture list is amazing. So, Karpathy, Howard from FastAI, Richard from Stanford, and so forth. So it's free. I think it's a collection of resources. I'm not sure if there's programming exercises, but there's slides, and there are videos. So I think this is their second version. I think somebody online was saying this is like their next generation. So I don't know when exactly this was recorded, but it looks like an interesting resource. The crash course on machine learning, it's a little bit more generic or not super related to deep learning. You can take it whenever you want. It goes in detail about loss, training and test set, validation set, how to pick your features, regularization, logistic regression, classification. Then it goes to neural network and how to do the neural network. So towards the end, so that's the concepts. Then you have something about ML engineering. How do you do this in practice? And then some real world data here. Intro to Deep Learning is MIT's website for their courses, and their courses are very, very well put together. They have their slides and their videos as well. Sometimes they have assignments as well. Yeah, they have code in some of their projects. So music generation, debiasing facial recognition system, that looks interesting. Pixel to control learning. I think they go into reinforcement learning in one of their sessions, which is interesting. Yeah, deep reinforcement learning. Fast.ai relies on PyTorch and goes into applications of PyTorch and applications of deep learning from very good instructors. And I think their concept is they build on hands-on approach first. You actually build something on with code, and then you actually learn the theory of how does it work and what does it mean. It's more of like a bottom-up approach or top-down approach, as they say it. Kaggle looks more of a machine learning and data science quick courses. So you learn about data visualization, feature engineering. You learn a little bit about deep learning. I don't know how much in detail it goes, but also like classical data science like SQL, geospatial analysis, machine learning, and NLP. Has a session on AI and game AI and reinforcement learning. I think
Kaggle calls their courses micro courses, right? These are just a couple hours a piece.
They're
yeah. Oh, have you taken this, David?
Yeah, I've completed almost all of them. The one thing I do like about them, and I'm not sure it's really the best for a group to do them, but the one thing I do like about them is they have a great system of hints and in the assignments part with hints and actually showing you some of the solutions for some of them. So it's almost like you're working with a professor. The professor will give you quite a lot more insight as if you're having trouble, right?
Yeah.
Whereas some other places you can just struggle, and there's really no place to go for help. So.
Did it take a long time to complete the whole thing?
No, each one's very fast.
Got it.
Yeah.
So maybe we can just take the whole thing and talk in the end of some of the issues we had or what we learned. Like, could be that kind of a session.
There's some good stuff. It's all text and examples. There's no videos or anything like that. But they do have assignments at the end of each class.
And you run on Kaggle, right?
It runs all on Kaggle. Mm-hmm.
Nice. The book I was talking about from Francois Chollet on the second edition is available. I think 6 out of 15 chapters are available. But when you buy this early access program, you actually get the first edition as well online for free. And if you look inside, it goes in detail about Keras and TensorFlow, neural networks, classification, regression, different data sets, fundamentals of machine learning, and some workflow in machine learning. It's very well set up. You can actually use the code here in many examples. Let me find one that There you go. You can actually copy the code. I don't think you can run it here, so you have to copy it somewhere else.
Can you tell if the second edition is significantly different than the first yet?
No, I haven't read any of the editions. I just bought the second one recently.
Okay.
Probably a newer version of TensorFlow, probably a newer version of other data sets. Then yeah, Ian Goodfellow and Benju and Aaron, they have this great book on more of the theory of deep learning. So I remember when I was looking at sequence modeling and all that, this is more from like an academic perspective of different neural networks. And we've seen like a few examples, but there's so many more that they go into detail here. This is more, I would say, from the theoretical part of it.
Yeah, I'd say they go into even more detail than Andrew's class.
Yeah.
On a lot of topics. Good stuff.
This book is, I've seen it online. I like the way they explain things. It's actually a little bit interactive. Let me see if I can find. Yeah, there are some, maybe the beginning, sorry. There's some option for you to actually control maybe the weight of the bias, and you can see how that affects your output. Somewhere here. Yeah, this to me looks more like an introductory course. Anyway, it's kind of hard to read as well. It's one column. So those are the resources I was able to find online. Again, could be, project related, which is always good. Could be resource related or learning something new. Think about it. I'm going to host a happy hour next week. Yeah, we're going to host a happy hour and we can talk about this in detail. But again, I think from what I heard, the next step would be this data and deployment specialization, simply because it follows TensorFlow. So if you want to join us, maybe you can start, checking it out. And next week we can talk more in detail about each of these topics or get in touch with some of the projects you've been working on. Cool. That's all the slides I had. Some other resources that I usually put here in the end, some other books and some other sessions. But I want to thank everybody. Let me see if there are any questions on the chat. Awesome. Yeah. I want to thank everybody for joining us. It's been a fun adventure, and hopefully we can have more guests and guests talking about their experience. And if you're new and this is your first meetup, thanks for joining us. And hopefully we'll see you again in our next adventure.
Thank you.
Hey, George.
Awesome. Thank you, everyone.
Thanks for hosting.
Absolutely. Have a good night and have a good weekend.
Thank you, George. Thanks
Bye-bye.
so much.
Absolutely. See you next Friday.
Thanks, George.
Thank you.